Okay, here's another example just to walk us through how to find the distance of a line on the coordinate plane, and we're going to use Pythagorean's theorem and the distance formula. So whenever we see it on a coordinate plane like this, I'm going to start off by using Pythagorean's theorem if I can form a right triangle. And in this particular case, I can. I'm going to take this dot right here and I'm just going to draw straight down. And then I'm going to take the other end point of that line and I'm going to draw straight over. And right there I formed myself a right triangle. So I'm going to use Pythagorean's theorem, which is a squared plus b squared equals c squared. To find out the length of this line right here, which is going to be the hypotenuse. This is going to be C. I'm going to label this as A and this is B. I know that this is C because it's the longest length, because it's also right across from that right triangle, or from that right angle right there. That means that it's the hypotenuse of the triangle. So in order to find out the value of A, I'm just going to count these. So it's 1, 2, 3, 4, 5, 6, 7. Let me double check that. 1, 2, 3, 4, 5, 6, 7. Yep. So A equals 7, and B, I'm just going to count these. So it's going to be 1, 2, 3, 4, 5, 6. B equals 6. All right, so let's plug that in over here. 7 squared plus 6 squared equals C squared. Well, 7 squared is 49, plus 6 squared is 36, equals C squared. I'm going to add those two together. Bring out that trusty calculator here. Hoping you can see that sum. What did we say? 49 plus 36. That's going to give us 85. And we have to get rid of this exponent, so we're going to take the square root of both sides. I'm going to say the square root of 85. It's going to be approximately 9.22. So C is going to be approximately 9.22 units, okay? So there's one more example of just how we can solve that on the coordinate plane. You're going to have to draw in some lines and make it a right triangle. That way we have both of our legs and we're going to be solving for our hypotenuse there for C. Now, occasionally, you're going to get something that looks like this. And this right here, you don't have to make any triangles or do anything fancy for that at all. You just need to count the units. So this right here is 1, 2, 3, 4. We know right there that the answer is 4. That's the distance there on the coordinate plane. Same thing if they're up and down. If they're just a vertical line, we're just going to count it. So 1, 2, 3, 4, 5, 6. 6. We just know right there that our answer is 6. We don't have to do anything else. All we have to do is count our units. So again, let's just go ahead and do number 3 because it's right there. I am going to draw in to where my points connect, both vertically and horizontally, to make myself a right triangle. And I'm going to have a squared plus b squared equals c squared. I'm going to say one leg is A, one leg is B, and then my hypotenuse is C, which is going to be directly over from that right angle right there. So A, I can just count, is 1 unit, so I'm going to have 1 squared, plus B is 1, 2 units. 2 squared equals C squared. So I'm going to have 1 plus 2 squared is 4 equals C squared. 5 equals C squared. In order to get rid of this exponent, again, take the square root of each side, and then put that into your calculator. So we're going to have the square root of 5. It's going to be approximately 2.27 is approximately C. Now, if you just put the equal sign when you're putting it in a Google Classroom, that is completely fine. You just need to know that's an approximation because we're rounding. So that's how we can do it when we see it on a graph. Now, the next way that we are going to be able to do this is when you're given 2 different points, we are going to use the distance formula. And the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That is our distance formula. So all we need to do right there is we need to plug in the correct coordinates. So I'm going to say that this first number they give me here is x1 and y1. And then the next number that they give me, I'm going to say is x2 and y2. So we're just going to plug that into our formula. So distance is going to equal the square root of, okay, so x2 right here, -7, minus x1, a -2, squared, plus y2, which we just said was -7, minus y1, which is 3, squared. All right, so we just filled it into our formula. Now let's do what we need to do. We're gonna follow PEMDAS. So we're gonna do parentheses first. So -7 minus -2. We know that that is going to turn into an addition problem. So we're gonna have -7 plus 2 is gonna give us -5. Plus -7 minus 3, that's gonna give us -10. All right, now let's do our exponents. We did our parentheses, let's do exponents. So -5 squared is gonna give us 25, because -5 times -5. Make sure if you're putting this into your calculator that you put your parentheses around that negative before you do the squared. Otherwise, your calculator is going to assume that it is -5 squared, which means that they're just gonna say it's -25. So make sure inputting that correctly is going to be very beneficial for you. Same thing here, so -10 squared, that's really -10 times -10, which is 100. All right, now let's combine our like terms there. So we're gonna have the square root of 125. And then again, put that into our calculator, the square root of 125, right there. And that's gonna give us 11.18. So our distance is gonna be approximately 11.18. All right, so that's using the distance formula. The main thing that you need to do is you're gonna have to write out these problems, especially if you are working digitally on Google Classroom. You are going to have to write these out on another piece of paper and solve them and then input your answer. So I can show you how, you know, it's the same thing. You're just gonna write down your problem. So if you have a piece of paper, we can go through the next one together just so we have a good idea. Let's do, we're gonna do the points 2, -9, and the point -1, 4. We need to know the distance between those 2 points. Now, one thing I can do is I can grab a piece of graph paper and I can plot those points on the coordinate plane, and that would be completely fine as well. Or we can use the distance formula. Distance equals the square root x2 minus x1 squared plus y2, I'm sorry, minus y1 squared. All right, I'm gonna label my points. This is gonna be x sub 1, y sub 1. It's gonna be x sub 2, y sub 2. Now, whatever's directly underneath there is all that I'm going to substitute in. So my distance is gonna equal the square root of x sub 2, we said right here is -1, minus x sub 1, 2, that quantity squared, plus y sub 2, which is 4, minus y sub 1, which is -9, that quantity squared. All right, distance is going to equal the square root of, let's do our parentheses first. Let's follow PEMDAS. -1 minus 2 is going to give us -3. Keep that exponent because we haven't done anything with it yet to get rid of it. Plus 4 minus -9. We know that's going to turn into 4 plus 9, which gives us 13 squared. All right, let's do our exponents. -3 squared, that's going to give us 9. 13 squared, that's 169. Combine our like terms. It's going to give us, what, 178. Now we need to find the square root of 178. It's going to give us approximately 13.34. So our distance is approximately 13.34. So you may have to do this. You're going to have to write down some work for one thing, but you may have to transfer it to another piece of paper. You know, doing it on the computer makes it a little bit more difficult, obviously, but it's no different than if you were doing it in your book. So if you had a worksheet that you couldn't write on or a page out of your book, just writing down your work, making sure that you put things in the correct spot. So the first thing I need you to do is write down your distance formula. That way you can just plug and chug right through there. Okay. Another hint might be to write down PEMDAS. That way you remember that you need to do your parentheses first. Okay, then write down your points. You need to label them so you know which one is x sub 1, y sub 1, x sub 2, y sub 2. Okay, your sub 1s are going to be in one coordinate point and your sub 2s are going to be in one coordinate point. So then you just take those, you plug them in, and then you start working through it. Remember, order of operations. Parentheses, exponents, multiply, divide, add, subtract, okay? So I'm hoping that helps. If you have more questions over this, feel free to contact me.